Hey guys, so I just launched the FET circuit simulator. I put it into symbol mode over here, and I'm just going to build a quick circuit here. What we're going to do is we're going to do actually we'll do like 3 resistors in series. Okay, so I'm going to go resistor, resistor, and one more resistor here. Join that with a piece of wire. Alright, so now we have current flowing. Now what I want to show you here is what we can do is take a voltmeter. Take this voltmeter and we can just stretch the wires wherever we need to. So we can actually measure the battery voltage just by touching the wires to each side of that one battery. The next thing you can do is move this over. Like, oh, look at now I have 12 volts. So if you measure across both, they're in series, the voltages add, 6 and 6 is 12. Good. So that we call a voltage gain of 12 volts. So the batteries are actually giving the electrons energy. How much energy? Well, if you look at the units for voltage, it's joules per coulomb. So basically, a whole lot of electrons flow through this circuit. If 1 coulomb is flowing, say each second, so that'd be a 1 amp of current, is 1 coulomb per second. So if we just kind of zoom in and take a freeze frame and look at that whole coulomb of charge, the batteries together would be giving them all in total 12 joules. So every coulomb that flows through carries 12 joules. What we're going to see next is how many joules are lost to each of these resistors. Now in this one, because the resistances are all the same, it's going to be 4 volts there, 4 volts here, and 4 volts here as well. Okay, so the voltage gain here of the battery, 12 volts, is then split evenly between the 3 resistors. Now let's see what happens when they go a little bit differently here. So what if I make this, let's make it 2. Then I'm going to make this one 4. And let's make this one 8. So we got 2, 4, and 8. Okay, now when we look at the voltage, across the 8 ohm, we have, you got to make sure that wire is touching there, 6.86 volts. Here we have 3.43. Here we have 1.71. So what you're seeing here is these 3 voltages, the one here, the one here, and the one here, all still add up to 12. Given that each resistor has the same current flowing through it because it's a series circuit, and actually we can prove that here with the ammeter. Now, normally speaking, when you use an ammeter, you need to break the circuit. So we're actually going to delete this wire. We're going to take the ammeter, we're going to hook it in where the wire was. And now you can see that the current is 0.86 amps. Now, if we lower the resistance of any of these resistors, start with this one, we'll see the current going up. Put it there now. We got 12 ohms of resistance and 12 volts, so that's going to give us 1 amp of current. Now, I suppose I could kind of prove this to you guys here. We could actually delete the wire here, put another ammeter in. 1 amp there as well. So in a series circuit, the current should be the same. And to measure current going through a series circuit, you just have to put an ammeter pretty much anywhere as long as you break the circuit and fix it by putting the ammeter back in. Alright, I'm going to stop this video. You've learned how to take voltage readings with a voltmeter. Just a reminder, we're not doing this at home with anything other than a small 1.5 volt battery or a 9 volt battery, but I'm not advocating that we do any of this at home with like actual electrical circuits or anything. Household circuits can be dangerous, so don't be playing with that.